The following video will present solutions to the QCE Year 12 Mathematical Methods Sample Assessment 2020, Paper 2, Technology Active. Multiple choice, questions 6 to 10. The technology utilised is the Casio CG50AU graphics calculator running operating system 3.2. Unless specified otherwise, default settings have been used. Question 6. All triangles with sides in the ratio 2 to 3 to 4 will be similar and will have the same internal angles, and so we can answer this question using a triangle with sides 2, 3 and 4. The smallest angle will be opposite the smallest side, which has length 2. For this triangle, we can write down the cosine rule linking its sides and angle theta. This equation can be rearranged, and we can use the Run Matrix app of our Casio CG50AU to find theta. Before performing this calculation, we will need to change our angle measure to degrees, as the Casio's default measure is radians, and the answer we're looking for is in degrees. Do this by pressing Shift and the menu key to open the settings. Arrow down to Angle and press F1 to select degrees, then press Execute. With that done, as shown at the top left of our screen, we can calculate theta using our rearranged equation. The value calculated corresponds to answer C. Question 7. One way to answer this question is to consider the second derivative of y equals x cubed minus 6x squared. This second derivative will be 0 when x equals 2, and as it is a linear function with a positive gradient, it will have a sign diagram that looks like this. As the graph of a function is concave downwards when its second derivative is negative, our answer is x is less than 2. Another way to answer this question is to draw the graph of y equals x cubed minus 6x squared in the graph app of a Casio CG50. This graph, drawn on the initial view window, isn't bad, but it seems that it will be better to focus on x between -1 and 7. I'm going to open the view window settings by pressing Shift and F3 and use these as my minimum and maximum values for x. This looks like a good domain, but now the Y scale needs some attention. If you have a domain that you are happy with, the Zoom Auto command can be very useful. It adjusts the Y scale so that all points within the current domain are visible. The Zoom Auto command can be found by pressing Shift, F2 for Zoom and F5 for Auto. Much better. Now that we have a good picture of the graph of the function, we can see that it is concave downwards to the left of the cubic's inflection point, which is in the vicinity of x equals 2. Because this is a multiple choice question where we can see that only one answer corresponds to this graph, we need look no further, and our answer is C. This question could have been asked in a way that required a more precise location for that inflection point. To obtain this, the graph of the first derivative of the function would be very helpful. This is because the turning points on the graph of the first derivative will occur at the same x values as the inflection points on the graph of the function. To draw a graph of the first derivative, exit to the graph editor. In Y2, press the Option key. Choose Calc by pressing F2. Select the first derivative by pressing F1. Press F1 to enter Y and enter 1, and press execute. Press F6 to draw both the graphs of the function and its derivative. As we can see, the minimum of the derivative lines up with the inflection point we're interested in. To locate the minimum on the derivative graph, open GSolve by pressing F5 and calculate the minimum by pressing F3. The graph of y1 is flashing, but it is not this graph we want the minimum of. Arrow down and the graph of y2, the derivative, will flash. Press execute and the x value that locates both the minimum of the derivative and the inflection point of the function is found. Question 8. The acceleration of a particle at time t equals 2 is equal to the value of the derivative of its velocity function at that time. Given the relative complexity of this velocity function, I'm going to calculate the value of v-2 in the Run Matrix app of my CG50. Currently, the angle measure is set to degrees, as I had selected that in a previous question. I'm going to need to change this back to radians to compute the value required in this question. Do so by pressing Shift and the menu key to open the setup. Arrow down to Angle, select Radians and press Execute. Now this is done, open the Math menu by pressing F4 and choose the first derivative by pressing F4 again. Enter the velocity function exactly as it is written. Arrow right, enter the value of 2 and press execute. Our answer, rounded to 2 decimal places, is answer A. Question 9. The probability in this question can be calculated in the Statistics app of a CG50. Open the distribution menu by pressing F5. Select the normal distribution by pressing F1 and opt for a cumulative calculation by pressing F2. Set the data to variable by pressing F2 and then arrow down to set the lower and upper values as required. In this case, we want the probability that a birth mass is less than 3,200 grams. So our lower bound is something approximating negative infinity, and our upper bound is 3,200. Enter the sigma and mu of the normal distribution under consideration. Press execute to calculate this probability. This result corresponds to answer D. Question 10. This confidence interval can also be calculated in the statistics mode of the CG50. Press exit a couple of times to return to the main statistics options. Press F4 to open the interval menu. To calculate a z-interval, press F1. Press F3 to calculate an interval based on one proportion. Make sure that the confidence level is the one required, i.e. 0.95 for a 95% confidence interval. Arrow down to enter the sample proportion as x equals 142 out of n equals 200. Press execute. The confidence interval calculated, with bounds rounded to 2 decimal places, is answer C.